We received a new question uh, about what are the essential components that we should put on or we should include in the HMI or graphic page. HMI as the interface between the machine and operator or the engineering team. So we design the machine, everything is done in the PLC programming, mechanical design, electrical design, and the instrumentations. The next step will be do the communication and HMI design. What should we include in HMI in order to have all the maximum functionality, and uh, it should be very easy for operator to operate the panel. This is an example. This is an example for a machine. In this example, you can see that we have many instrumentations, transmitters. Um, Transmitters are connected to the analog input modules, and they are processed from the raw digital values into meaningful floating point variables. So we have these floating point variables stored in some memories inside the PLC, and by using the softwares available for each manufacturers, or using some interfaces like OPC, there's possibility to bridge between HMI and PLC. There's a possibility to read those analog values. So as an example, PT5111 is one of those transmitters, or temperature transmitter, pressure transmitters. There are wide variety of analog values in the machine. The other essential component that should be included. So the first is the analog input values. Analog input values that are read from transmitters. From transmitters. Status of machine. Machine status. So if it's out of service, in run mode, stop mode, shutdown mode, permissive, and standby mode, everything. And the indication for all electrical components. So indication for all electrical components, we have here the main drive, and the indication for all other drives. So indication for on-off status, on-off actuators, such as valves. As an example, we have a valve that the open and close status is important here for us, and some small drives, and a giant drive here. That is the status open. In this case, open and close is important for the valve. In here, open and close is important for us, and in here we are happy to see if the drive is on or off during the operation. And let us move to the next page. They are the same HMI. So this is the next phase of the machine. In this phase, it's in the startup. It's in production mode. So the main drive is on. The valve, the production valve is also open. And as I mentioned, this is the signal command to analog output, CMD to analog output, and the feedback that are read from analog input. These are all variables in um, digital representations. They are all converted to the floating point variables. So let us see. I forgot that to mention it as at the beginning of this presentation. You should first find mm, a picture of the machine. If the machine has several parts, 5 parts, 6 parts, and one overview, so you need to put the overview in the first starting screen, and mm, possibly by some navigation buttons here, like these navigation buttons, you can navigate to those other pages or screens. Mm, so let us move to the next page. You can also include some buttons inside the overview if you want to manipulate some variables, because you cannot uh, make the overview page very complex, so you need to just put some buttons and some small windows, to pop up small windows here and do some other tasks. So we have many tasks here. This is part of a simulation of a package, so there are many tasks for simulation. This is a fellow simulation, and when I press this button, this small window will pop up, and I can do some task. I can perform some tasks regarding to the fellow manipulation. And so this was a simulation. In this simulation, I run the machine and put it in normal operation mode. Try to create some faults, and I just created a trip here, a trip signal here, trip due to surging, and these are also a status of machine as the machine is in the stop phase. It means that um, it's still rotating in order to lubricate some uh, important mechanical parts and cool down the whole machine gradually. And there is a alarm bar here in order to inform the operator team what happened, what was the cause of trip. uh, I guess that's all basic things you need to include and in an overview, possibly in a machine with a complex process intervention and process signals. You need to include trends in order to trace malfunctions in the machine, alarm messages, trip messages, and as much as information you can provide. There is a possibility to write some variables like set points from the HMI. You need to provide some instruction in order to manipulate variables inside the PLC. It can be as easy as putting some number with input output properties, or in DCS applications you may have very complex faceplates to include several parameters, like a PID controller in a PCS, it has many parameters to manipulate. And in case of security, even security and safety is included. The features may be different. I will discuss that in another topic later. If in case of safety, if we want to manipulate the safety variable inside the failsafe CPU. It's possible to be done from WinCC, but there are some the special failsafe commands from WinCC to run and to initiate. So there are many other options, like as user authentication to permit internal variable of CPU manipulation, or even run, stop, and change variable inside the PLC. So we need to have the user authentication in order to make sure that the authorized people, trained people, they have access to the machine. If you ignore this, the security of the machine, that will be a very big trouble for during the operation. So that's all for the star. Possibly I can add some other mm, mm, tips and tricks related to this topic in the next videos, and also something about how to manipulate failsafe values from WinCC into a failsafe CPU. So I stop the video here, and thank you for watching.